Okay, in this video I want to talk about row-echelon form, and this is related to Gaussian elimination, so we're going to see why this is important in a little bit, but for now let's just talk about what exactly does it mean. So a matrix is said to be in row-echelon form if three things happen. First of all, any rows of all zeros are at the bottom. Second of all, the first non-zero entry in every other row is a 1, which we call a leading one. So assuming that you have your rows of all zeros at the bottom, we want to have every other row, any row that has something other than 0, the first number that's not a 0 should be a 1. And then the last restriction is that the leading ones should be in order from top left to bottom right. Which is worded as each leading one is right of any previous leading ones. So basically, if I circle the ones that are the first entry that is not 0 in their row, then they should be marching in order. That's echelon means marching or in order, and so row echelon means our rows are in order. Okay, so let's look at all these matrices I already wrote up on the board and talk about which ones are in row echelon form, which ones are not in row echelon form. Okay, so top left. Rows of zeros are at the bottom. There aren't any rows of zeros, so it's irrelevant. The first non-zero entry in every other row is a 1. So first non-zero number in each row, so that's a 0. This is the first non-zero number. This is the first non-zero number. The first non-zero number in each row is a 1. Perfect. Each leading one is right of any previous one. So this one is to the right of the previous one. This one is to the right of the two previous ones. So they're in order. They should be going top left to bottom right. And so you can maybe kind of see hints of Gaussian elimination showing up. This looks an awful lot like our triangular form that we were talking about. We're placing a strange amount of impact on the fact that there are ones. So anyway, this one seems okay. I haven't found anything wrong with it. Second one. Rows of zeros are at the bottom. There are no zeros, no rows of zeros. This is a row with some zeros, but it's not a row of all zeros. The first non-zero entry in every row is 1. So 1 and 1. Yep, looks okay. And then each leading one is to the right of any previous leading ones. So yes, they are marching in order. They don't have to be exactly diagonal from each other. They could be over quite a ways. That's totally fine as long as they're not out of order. Speaking of which, looking at the next example, there's no rows of zeros. We do have leading ones for every row, but the leading ones aren't in the correct order. So this is not going to be in row echelon form. So because our top two rows are in the wrong order, it's not in row echelon form. Okay, I feel like this is our first time that we actually saw a row of zeros, and this row of zeros is at the bottom, so it looks good. Every other row, rows that don't have all zeros, I looked at my first non-zero number. It is a 1, so that's good. And is it right of every other leading one? Well, there aren't any other leading ones, so there's nothing wrong with it, so I guess it's okay. If you can't break it, then I guess it's okay. Okay. Next example, there are no rows of all zeros. First non-zero number, that's a 0, that's non-zero, 0, 0, that's non-zero. But notice I circled a 2. We don't have a leading 1 in our middle row. So this matrix is also going to fail because it doesn't have a leading 1 in its second row. Okay. This example, let's see. There are no rows with all zeros. Every row has at least one non-zero number. And the first non-zero number in each row is that, but they're not in order. It's the same problem as this one. So not in order, so not in row echelon form. This guy, we have leading ones. But we also have a row of all zeros, and the rows of all zeros are supposed to be at the bottom. So that's the only thing wrong with this one. This row of zeros should be on the bottom, so I have to throw that away as well. Let's see. This one doesn't have any rows of zeros. Let me look at the first non-zero number in every row. Okay. I feel like maybe there's a difference between a leading 1 and a leading -1. So I think this one is also going to fail. Same reason this one failed. The first non-zero number wasn't a 1, it was a -1. So that one fails. And so the only ones on the board that are actually examples that are in row-echelon form are these 3 on the top right. The other ones all fail for one reason or another. Okay, so hopefully we've seen enough examples now for you to kind of get what's row-echelon form and what isn't. In the next video we'll talk about how to use it to solve a system of equations.